Problem number 49. I tell you to evaluate this integral. I tell you, you better change the order. So let's change the order of integration here. Let's follow the advice. Okay, what are our bounds here? X is between 0 and 1. Y is between x to the 2/3 and 1. Okay, so let's draw a picture here. X is 0. X is equal to 1. Y is equal to 1. And y is equal to x to the 2/3. That will look something, I mean, the exact, drawing isn't too important, but it will look something like this. The important thing is that it goes through the point 0, 0, and 1, 1. The final thing that we have to realize is which one of these two regions are we shading right now, this one or this one. So x runs from 0 to 1. For a fixed x value, y goes from x to the 2/3 to 1. So this is the region that we care about. And right here is the curve y is equal to x to the 2/3. Okay, so that's the setup. Well, we want to change the order integration. So we need to slice things horizontally, not slice them vertically here. What's going to be the bounds now? So the y bounds need to be constant. X bounds potentially depend on y. It's pretty clear here y is going to run from 0 to 1. X is going to run from, for a fixed value of y, the smallest x can be is 0. And the largest x can be is given by this curve here. Now if y is equal to x to the 2/3, inverting this formula, x will be y to the 3/2. So the biggest that x can be is y to the 3/2. Okay, so coming back over to writing down our double integral now. This is going to equal the integral y runs from 0 to 1. X runs from 0 to y to the 3/2. Now we're still integrating x e to the y to the 4th dx dy. So before I do anything else, let me just observe here something. Right here, x e to the y to the 4th, if we try to integrate this with respect to y, we'd be, x is essentially constant, we'd be integrating e to the y to the 4th. I sure don't know an antiderivative of e to the y to the 4th. And I don't think you do either, at least not in terms of elementary functions. So that's what makes, I tell you, don't integrate it in this order. But now we get to integrate with respect to x first. So when we integrate with respect to x, so e to the y to the 4th, that's just a constant. X, antiderivative of that will be x squared over 2. Plug in x is equal to 0 to y to the 3/2. And what do we see is going to happen here? E to the y to the 4th times, when we plug in y to the 3/2 into x, y to the 3/2 squared is y cubed. We still divide by 2. Then there's going to be a minus 0, which we can just drop that. And look at what just happened here. We were trying to integrate e to the y to the 4th. All of a sudden, a y cubed factor appears out in front. And this is going to let us do substitution really nice. So our substitution is going to be u is y to the 4th. Du is 4y cubed dy. We have a 1/2 we have y cubed over 2 dy, so if we divide both sides of this by 8, du over 8 is equal to y cubed over 2 dy, which is exactly what that factor is. Okay, so what happens now? This is going to equal integral from y from 0 to 1 of e to the u. And by the way, let's be careful here. I need to be careful. U is y to the fourth. If y is 0, u is 0. If y is 1, u is 1 to the fourth is 1. So bounds here, u is running from 0 to 1. Times e to the u times 1/8 du. And now we can easily evaluate this. 1/8 e to the u, plug in u from 0 to 1. 1/8 e to the 1 minus e to the 0 is 1. So yeah, once again, change the order of the integral. It will make our life a lot easier.